Hi, I want to walk through problem 7 from chapter 5 of DS Malik C++ Program Design, including Data Structures, 8th edition. The reason I want to walk through this is it demonstrates how to walk through a sequence of values. So I've got the problem description up on the board, or up on the screen, excuse me, and we see that n is some number. And it's got this weird symbolism, ak minus 1, ak minus 2, dot, 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 a1, a0. Anytime you see scenarios like this where you have a sub k minus 1, this is a sequence of some type. And typically you solve these with a loop. A sub k would be the kth number in the sequence. If the number is 71328, there are 5 numbers in there, so k would be 5. And a sub k would be 7. So likewise, when we look at this number, 8784204, there are 1, 2, 3, 4, 5, 6, 7 values in there, and 8 is at position 7 or a sub 7. And then they apply this bizarre little formula. A sub 0 minus a sub 1 plus a sub 2 minus etc. Basically, you're starting at the end of the number, and you subtract off the odd numbers, you add on the positive numbers, odd and even being position, not oddness or evenness of the digit itself. Now, what this problem is going to calculate is whether or not this number is divisible by 11. Now, you know and I know I could do that with, n% 11 and be done. But the idea here is not the divisibility by 11. The idea is to walk through the number sequence and see how to apply it in code and write an algorithm that pulls this off. There are many ways I can pull this off. I'm going to do it with some while loop and some math, and I'll walk through the end of the number up to the beginning. So I'll start at the end and go back to the beginning. All right, so I have here basic main. Got your standard pod includes, I've got using namespace, etc. And rather than getting some input, I'm just going to hard code my values. I'm going to use the book number 8784204. I'm going to need a couple variables through here. I'm going to use that for each digit in the given number. The total is going to be the total that's calculated. And I might need a count variable. Actually, I'm going to need a count variable. So I'm going to figure out whether or not it's even or odd. So what I'm going to do is I'm going to use a trick about modding. If I take, and this is just the thought process here, okay? If I take the number 15% 10, I get 5. If I then take 15 divided by 10, I get 1. If I keep looping this process, eventually my number will get to 0. I'll be able to walk backwards through my number one step at a time, eventually getting to 0. The reason I get to 0 is because this is integer division, not decimal division or float division. So I'm going to create a while loop and keep going while number is greater than 0. And I just want to prove to you right now that this works. So I'm going to get the individual digit. So get that last digit in the number. And then I'm going to lose that last digit. That will essentially remove the digit we will lose that initial number, and that's okay. I can hang on to it with another variable for once. And now, just to prove this works, okay, see, I'm also going to see out my original number here, so I don't lose it. Why are you angry? Oh, because it's n instead of n now. Okay. So my number will appear, and then it should go backwards 4024878. Let's see if I'm right. Look at that. Original number, and it walks backwards 4024878. So my algorithm works. I walk through my number step by step. This algorithm, while you may seem to think it's silly, it has a lot of uses. This idea of walking through a number. You probably have a credit card with a 16-digit number. That number is generated with the LUN algorithm, L-U-H-N. And to verify a credit card number, the LUN algorithm does something very similar. It walks through your credit card number and does math to the individual digits, depending on whether it's even or odd. Then if all that number is divisible by 10, you have a valid credit card number. So the algorithm is valid. It's worth working on. All right, so now I've got it displayed. I can comment that out. So I now need to deal with the logic from the book. And that basically said when it's even, add them. When it's odd, subtract them. I like this -1 to the k power. That's really slick. But sometimes slick is not good programming code. So I'm going to make something really obvious. I'm going to if it. Now I've got a count variable going on that I'm going to use for even or odd. And I'm going to say if my count is odd or even. So if my count is even, I'm going to add digits. So based on my algorithm that the book has given me, I'm going to add in the digits if it's an even number, and I'm subtract off the digit if it's an odd number. And I can get that with that simple if logic. If count percent 2 equals 0, else if count percent 2 equals 1. You know I prefer to explicitly test all of my if conditions rather than resulting in an else. I know that a number can only be even or odd. I know logically the else should be okay, but I'm paranoid. And then so I can do my math right, I'll do a count. Algorithm's getting a little bit long. Let me comment the end of my for loops. Always a good strategy to comment the end of your loops, especially when it's longer than your screen. You don't get lost that way. Okay, so now we need to determine the rest of the algorithm. The rest of the algorithm says, if I total this up, if this number is divisible by 11, then it's divisible by 11. If it's not divisible by 11, then the big number isn't. So I'm going to check that total. So total percent 11 is equivalent to 0. This means it's even, or it's divisible by 11. I put a cool little space here because I'm about to get clever on you. Before my while loop, I displayed my number. I'm going to get rid of the endo here. So now my output should say number is divisible or is not divisible. Now, according to the book, our number 8784204 Should be divisible by 11. Okay, so we have a glitch. Everything's not divisible by 11. The reason is I forgot to initialize something. I need to set total equals 0. By setting total equals 0, though, my math makes sense. So now I'll set this back to 4. 8784204 should be divisible by 11, and it is. 8784205 save it. 827405 is not divisible by 11. So the magic here is this while loop. Keep looping while numbers greater than 0, and I manage that by %10ing the last digits and then dividing by 10. There are other ways you could have done this. I could have made this a string and walked through the string from reverse. But this I like because it's mathematical and it uses tools you already have.